Space. It's full of wonders, celestial ballets choreographed by the laws of physics, a cosmic ocean with stars like ships sailing across the void. But what if I told you there's something out there where those laws, those very rules of reality simply break down? Yes, I'm talking about black holes. Regions of space-time where gravity is so strong, so all-consuming that nothing, not even light, can escape its clutches. Imagine, if you will, a cosmic abyss, a point of no return, a place where the fabric of space-time itself is stretched to its breaking point. What happens to the stuff that falls in? Does it get crushed into oblivion? Does it travel to another universe, another dimension beyond our comprehension? The answer is a journey into the very heart of the unknown. Stay with me, and by the end of this cosmic ride, you'll have a newfound appreciation for the terrifying beauty of black holes. And don't forget to subscribe for more mind-bending explorations of the cosmos. Before we talk about what lies a black hole, we need to understand what they are in the first place. Picture this, a massive star, many times larger and heavier than our sun, nearing the end of its life. For eons it burned bright, a cosmic furnace fusing hydrogen into helium in its core, a delicate dance between gravity trying to crush it and nuclear fusion pushing outward. But even stars have a lifespan. Eventually, the star runs out of fuel. The outward pressure from nuclear fusion weakens, and gravity, that relentless sculptor of the cosmos, takes over. The star's core collapses in on itself, and if it's massive enough, this collapse doesn't stop. It continues to crush down, squeezing all that matter into a smaller and smaller space. Imagine the entirety of our sun compressed into a city, then a town, then a pinhead. This relentless compression creates a region of space-time where gravity is so intense that nothing, not even light, the fastest thing in the universe, can escape its pull. And that, my friends, is how a black hole is born. A cosmic abyss, a singularity where the laws of physics as we know them break down. We can't see a black hole directly since no light escapes it. It's like trying to see a black cat in a coal cellar. But we can detect their presence by their effects on the surrounding environment. Imagine a cosmic whirlpool, a maelstrom of gas and dust swirling around an invisible drain. That's what astronomers look for, the telltale signs of matter being pulled in, heated to millions of degrees, and emitting X-rays as it spirals toward the event horizon, the point of no return. Black holes are not cosmic vacuum cleaners, though. They don't suck up everything in sight. You could be orbiting a black hole right now, and you wouldn't even know it unless you got too close. And by too close, I mean crossing the event horizon, the point of no return. But what happens when you cross that invisible boundary? What awaits at the bottom of this cosmic abyss? That, my friends, is where things get really interesting and a little terrifying. Fasten your seatbelts, cosmic explorers, because we're about to take a hypothetical plunge into a black hole. Now, I say hypothetical because, well, no one has ever ventured past the event horizon and lived to tell the tale. But thanks to the mind-bending laws of physics, we can at least imagine what such a journey might be like. Let's say you were an intrepid astronaut, piloting your spaceship toward a black hole, eager to unravel its secrets. As you approached the event horizon, you'd start to notice something strange. Time, that constant companion, would begin to behave very oddly. To an outside observer, someone watching you from a safe distance, you would appear to slow down, your spaceship stretching and distorting as it got closer to the black hole. Eventually, you would freeze at the event horizon like an image stuck on a cosmic pause button, forever frozen in time. But from your perspective inside the spaceship, things would feel quite different. You wouldn't notice time slowing down or your image freezing. To you, time would continue to flow normally. However, you would notice the incredible gravitational forces at play. Gravity, remember, is not uniform throughout space. It's stronger the closer you are to a massive object. So, as you approach the black hole, the gravitational pull on your feet would be much stronger than the pull on your head. This difference in gravitational pull across your body would create an intense stretching sensation, a process scientists affectionately call spaghettification. You'd be stretched out like a cosmic noodle, becoming thinner and thinner as you fell deeper into the black hole's grasp. Now, you might think this spaghettification would be a rather unpleasant experience, and you'd be right. It's not exactly a walk in the park. But let's say, for the sake of our cosmic adventure, that you had a spaceship made of some super strong spaghettification-resistant material. You survived the stretching, but what happens next? Where does this cosmic drain lead? Chapter 3. inside the belly of the beast, decoding the singularity. We've crossed the event horizon, survived spaghettification, and now we're falling into the very heart of the black hole. So what's next? Well, this is where things get really weird, even by black hole standards. You see, our understanding of physics, the very laws that govern the universe, they kind of break down at the center of a black hole. At the heart of a black hole, according to our best theories, lies the singularity. Now, the singularity is not a place you can visit or a thing you can touch. It's a point, an infinitely small point, where all the matter that's ever fallen into the black hole is concentrated. Imagine all the mass of a star, maybe even hundreds of stars, crushed into a point smaller than an atom. At this point, density and gravity become infinite. Time and space, as we know them, cease to exist. The laws of physics, as we understand them, simply cannot describe what happens at the singularity. It's like trying to divide by zero. The universe itself seems to glitch. So, what does this mean for our intrepid astronaut? Well, it's not good news. At the singularity, you wouldn't simply be crushed or ripped apart. You would be spaghettified, yes, but you'd also be compressed. All your atoms squeezed together until they became part of that infinitely dense point. That's the thing about black holes. They don't just devour matter and energy, they erase information. Your past, your present, your future, it would all be mashed into one cosmic smoothie, indistinguishable from all the other matter that's ever fallen in. But the singularity is not the only theory about what lies at the heart of a black hole. Some physicists believe that black holes might be portals, tunnels, or maybe even shortcuts through the fabric of space-time. Imagine, if you will, that instead of being crushed into oblivion, you emerge into another universe, another dimension, perhaps even a mirror image of our own. It's a mind-bending idea, and while it makes for great science fiction, there's no concrete evidence to support it. Still, the universe loves to surprise us, and what we don't know about black holes far outweighs what we do. Chapter 4, Earth versus Black Hole, a Cosmic Nightmare, or Not. We've journeyed into the heart of a black hole, explored the mysteries of the singularity, and pondered the possibility of cosmic portals. But you might be wondering, what if a black hole came knocking on our cosmic door? What would happen to Earth? Well, first, let me assure you that the closest known black hole is thousands of light years away. That's very, very far, even by cosmic standards. So there's no need to panic just yet. But for the sake of cosmic curiosity, let's imagine a rather unlikely scenario. Imagine a black hole just wandering through our galaxy, stumbles upon our solar system. Initially, we wouldn't even know it was there. Black holes, remember, don't emit light, so we can't see them directly. But we'd start to notice their gravitational effects. The orbits of the outer planets, those distant sentinels of our solar system, would be the first to be affected. Their paths would wobble, their once predictable dances disrupted by the unseen intruder. As the black hole drew closer, its gravity would wreak havoc on the inner planets, including our own. Tides would rise, oceans would surge, earthquakes would shake the very foundations of our world. And that's just the beginning. As Earth fell deeper into the black hole's gravitational grasp, the process of spaghettification would begin. But unlike our intrepid astronaut from earlier, Earth wouldn't have the luxury of a super-strong spaceship. Our planet would be stretched and squeezed, pulled apart like a cosmic piece of taffy. The atmosphere would be stripped away, oceans would boil off, and the very crust of our planet would crack and crumble. It would be, to put it mildly, a bad day for Earth. Eventually, what was once our home, our pale blue dot, would be nothing more than a stream of atoms spiraling down into the black hole's event horizon. But here's the silver lining, if you can call it that. The destruction of Earth by a black hole would be incredibly quick. There wouldn't be time for prolonged suffering or existential dread. In the grand scheme of cosmic time, it would be like a spark extinguished in a heartbeat. So while the thought of a black hole devouring our planet is undoubtedly terrifying, it's important to remember that it's a highly unlikely scenario. Black holes, cosmic enigmas wrapped in layers of gravity, time, and space. They challenge our understanding of the universe, push the boundaries of physics, and remind us just how much we still don't know. What secrets do they hold? What wonders and terrors lie hidden behind their event horizons? Perhaps one day, with advancements in technology and a little help from the universe's penchant for surprises, we'll unlock the secrets of these cosmic titans. Until then, we can marvel at their power, ponder their mysteries, and let them remind us that the universe is a far stranger, more wondrous place than we could ever imagine. If you enjoyed this journey into the heart of a black hole, hit that like button and share it with your fellow space enthusiasts. And don't forget to subscribe for more explorations of the cosmos.